There. I think we're good.
Cool,
man. Well, thanks for doing this. This is really cool. I was like looking forward to this conversation. Last couple of weeks, you did this like really great session on reinforcement learning here at Stadium, and it was like a really eye-opening session, I think, for me and for many people that were attending, because like we not just like got a sense of how important reinforcement learning was, and kind of how important it is, not just for what the software we're using now, but how important it is for like software moving forward. And that was the reason why we even did this. But then you also kind of showed us like what is happening at the absolute frontier of that, right? And so I thought that was really great. And so what I wanted to do today was just like get into that a little bit more. I want to talk about you. I want to talk about your background, the things that you're doing at Everywhere.dev, and yeah, just get into it. So thanks again for doing this, and maybe start off by like a quick intro to yourself and what you're working on now and kind of what led you to this.
Yeah. So as you mentioned, I'm working on a product called Everywhere.dev, which I'm sure we'll talk about more, but is generally a cloud environment for AI, whether it's agents or some of the new training use cases that are really exciting. And so really trying to think kind of ground up how you might build a cloud for some of these tasks specifically. And before that, I was working at Cloudflare on their Workers AI product. And so, building the servers essentially that are used for AI inference, and worked on things like the LoRa feature that they have on Workers AI. So for kind of using or adapting large language models with your own trained weights. And before that, a few other startups, a startup that worked generally on AI chatbots for upsells on e-commerce stores, so Shopify.
Right.
Really ever since it's been possible that large language models have been even close to capable enough for these kinds of for any kind of use case, been working on these kinds of problems, but more recently actually somewhat moved away from that and more towards the infrastructure side, because I think there's just so many really interesting problems to solve there.
Yeah.
So that's what I've been doing for the last few months.
That's cool, man. Let's get into it. So like how I think would be super useful to just give myself and just everyone the sense of appreciation for reinforcement learning environments, right? Why are they so important? Like, why is it so important for us to like understand these things and to understand why like it's such an important part of reinforcement learning, right?
Yeah.
Like, what is it about an environment and why is it a problem right now, right?
Yeah, it's I think maybe the first thing to say is that there have been reinforcement learning is a pretty general term, and it refers to any model architecture where you are training, you're updating the weights based on feedback that you're providing the model from some kind of environment. And so, especially in robotics use cases, this has been well known as a tool to, if you've seen even very early or relatively early, you can think back to like Boston Dynamics videos of, probably in 2016 or something or earlier of they had these robots doing backflips, where they have trained these in these environments, these virtual environments that attempt to simulate the real world and provide some kind of feedback in those environments that we hope is similar enough to the real world that you can then have those models affect the same actions in the real world. And so it's actually, I think, the thing that is specifically interesting today is quite narrow in the field of reinforcement learning. Obviously, there's lots of things that are very exciting, but the kind of subset of this that I'm very excited about is specifically the applications that are now possible with large language models. So what's very new today, is that one, large language models exist at all, and that they are able to, follow very complex instructions, and that the question becomes effectively now, how accurate can we make these models? And the problem that a lot of labs have been working on is effectively around data and reinforcement learning from human feedback, which is, I think, something people at a minimum have likely heard about. One of the perhaps underappreciated or under talked about anyway reasons why that's so interesting is because of you're able to make use of more data much easier by training a model with human feedback that then is able to tell you in the future with new data, what would my human have said, essentially. You've trained the model, you trained a different model to be able to reflect what a human would label effectively. And that allows you to scale your training because you're able to make use of much more data. But what is specifically interesting today is that now, we can kind of take away the human part in reinforcement learning from verifiable rewards that I talked about in my talk. And the really interesting thing is that now this is really approachable for anyone, in my opinion. I mean, obviously there's some technical bar, lots of things you have to learn, but previously, if you were to train one of these models that would be very accurate at labeling data, you still need humans that are experts in those fields. And what we're kind of proving today is that you can develop programmatically ways to improve models without having to do that, and that there's a lot. It's just very clear there's a lot to explore. Like there's this can be pushed pretty far. And so it's this specific area that I'm very excited about.
So RL is the broader space. There's reinforcement learning with human feedback. There's reinforcement learning through verifiable rewards. There's also reinforcement learning through AI feedback. And verifiable rewards specifically is something that is essentially like, it's a restricted, like the domain that you're interested in is essentially like, it is one in which verifiable rewards can actually be applied. It's like a good playground to do verifiable rewards, because the domain is typically in the world of it's in the world of a computer. Like it's not a real world application yet. Is that fair to say? And that's the part of the problems that you're focused on right now with the environments you're creating with Everywhere.dev. So if I am interested in essentially doing RLVR in environments that are virtual environments, either a specific application or specific OS that I need to spawn really, really quickly to test something, those are the types of environments that you're helping people with.
Yeah, and it's specifically in my case, I'm really interested in the computer use automation.
Right.
Not to say, I think when people hear that, they probably go to thinking a mouse clicking web page, but I more mean direct access to a terminal where you're editing files or executing programs one of the reasons is, so if I were to back up, I would say there are two perhaps related but separate reasons that I think that this problem space is so interesting. One of them is the training aspect that we'll talk about, but the other is just that if you are to take a foundation model that we have API access to today, there's really incredible opportunities to put them to work per se.
Yeah.
And we're at the point now, especially with GPT-5, where it's clear that that you can have these things do meaningful tasks unsupervised, and the accuracy is high enough that if the environment that the model operates with, the context or prompting is specific to that task, that you can accomplish you can accomplish real work. And I think it's like, what's the difference between it writing for you a single file of Python code and and like quote unquote real work. And I think to me the difference is when the model can, one, make multiple actions, and it can correct itself from pretty significant mistakes, and in a way that a human would. Like, you tell a human to do something, as they go through the process, they will make small mistakes, they will adjust their approach, they'll learn from they'll learn from that. And this is obviously not happening in the model weights. This is happening in the context of the prompt. You think about like user and assistant messages as is commonly depicted in these APIs. So it's happening in the context, but it's still happening. It's still because of reinforcement learning approaches that these labs like OpenAI have taken. You can now do that today, and so providing models, providing agents with an environment that can be tailored for a task is really important.
Yeah.
And so that's one piece, and the other piece is training. So when you then go to say, well, I want to actually train a model and update the model weights based on feedback that I've developed in an environment where I give it a task, and in addition to providing an environment to actually execute the task, I'm also spinning up many of these environments, and I'm trying to use the feedback from the mistakes that a model makes to or the things that it does well, to identify what those are, to algorithmically reward or quote unquote punish it for and to use that to train a model that is not only an agent that you've designed programmatically, but the weights are specifically now fine-tuned for that task, so that it's much more accurate than you could than something you would be able to do out of the box with prompting in GPT-5.
Yeah.
And
Do you feel like we've reached a plateau, or are going to be reaching a plateau with how much you can actually achieve from just the model itself, versus what essentially you get from these models running in these environments? Like, do you think these environments are essentially this like essential source of new knowledge that is like filling in a lot of blanks for these models that will essentially help them achieve better, like markedly better results? Is that what do you think that, like, how are you feeling in terms of like model progress these days, right? Like, are you seeing a plateau, or are you noticing it? How do you feel about that?
I think I think it is extraordinarily exaggerated, the things that people are saying about there being a plateau, because people are saying that.
Yeah, I was just wondering what your perspective is on it.
Yeah, and I think it is extraordinary how wrong that is.
Yeah.
And I think that I think that it's also fairly obvious. Now, I think where that comes from is primarily GPT-5. I think the release of GPT-5 was poorly received, and people are almost looking for something to to like call out as as evidence that there's a plateau.
Yeah.
Because to some extent, I think people want there to be a plateau, because then it's like, not as stressful.
Yeah. Exactly.
Unfortunately, I think that so I actually think that having worked on inference infrastructure gave me a bit of an interesting insight into this, where you kind of realize when you're making resource trade-offs and you're managing which models, like the scale that you operate a given model. This is like a really hard, like inference is a really hard workload to optimize.
Yeah.
And the first thing that I thought when I saw that they did a model router with GPT-5 is like, that is the dream. If you're managing inference infrastructure and you can on a whim start routing to a smaller model and not have to explain yourself, because it's a system. I mean, that's what they called it in their model card. They said GPT-5 is a system.
Yeah.
Where, I mean, really, it's probably the same model that has been quantized, and that when they are breaching, they're having capacity issues, they can without having to explain.
Exactly.
You can still meet your SLAs and whatnot without having to explain yourself.
Yeah, there's no reason why. I mean, if I'm answering a question or asking a question that is a basic question, I say no. I want to put GPT-5, I want to put GPT-5 for agent mode on it with deep research, but it's like a one-shot question. It's like something that a mini model can answer. There's no. I see them seeing that as being a bug almost, and I would probably guess that because most of the people that are using GPT, like ChatGPT these days, there's a lot more now, but there's many early adopters that will use it, and they will just want to push the model to its fullest limit and want to test those edges and ask it questions that probably it can answer with a mini model at the same level with the same level of user satisfaction, the user gets what they want out of it. So I see it from a resource management standpoint. Having that as a lever is essential, right?
Yeah.
And being able to say okay, instead of saying, hey, this model is having capacity issues, it's just downgrade it temporarily. And from a customer service standpoint, you're the number of support tickets you probably get as a result of that, or is going to be markedly different. So it's pretty smart. So in terms of what you're building at Everywhere, who is the customer that you think is who are the types of people that you're talking to now? I mean, obviously with whatever degree you can talk about this, that are having an aha moment with the product, where they're seeing hey, this is actually helping us do this large scale environment creation in a way that is manageable, right? We're literally not having to spin up thousands of Docker instances ourselves. We're literally just in through one easy dashboard or one easy interface, we're able to manage many workloads of environments spinning up and spinning down, things like that. Who are the types of customers that you're finding are doing these types of things?
Well, so I think there's two, and they're perhaps very different, and I think they're different because of the adoption and general awareness.
Yeah.
So there's the kind of cutting edge startups that are training their own models, and they are, people who are experts in their field, who just they know exactly what they need. They know exactly the infrastructure they need, and they just need it to work. They need to be reliable, and they need to do a lot of experimentation. These aren't. I think that unlike a lot of cloud workloads, these you need many instances of your environment. You need to have many iterations of your environment. And it's quite spiky, the extent that you scale up and down. So these are things that are, I think, quite unique. And then there's also, and where I think most people have the most exciting opportunities for businesses right now are the second category, which is kind of business, enterprise, and even smaller businesses where they have identified that like AI can be used for automations, but maybe they haven't quite identified the approach they're going to take. And I think many people have looked at these drag and drop tools. They've looked at like these workflow builders, and where I think people have this aha moment is when you realize that you can have these environments adapt to your task. So it's actually quite a bottleneck to say, I'm the workflow builder, I'm gonna like be the human in this clicking around. Like, you don't want that. You want a self-optimizing system. You want a system that figures out why it's making mistakes and then it improves itself. Whether that's through actually updating the model weights, or I think for most people more practically is updating the environment.
So you are essentially, that is a form of reinforcement learning in and of itself, right? Like the infrastructure, the product to spin up these environments is using its own reinforcement learning loop, essentially, to instantiate them more intelligently, to manage them more intelligently.
Yeah.
Okay.
Yeah, I mean, that
makes sense.
And I think that's just the thing that is, because I think a lot of companies aren't in the place where it makes sense to start training unless they really are they're either a research lab or they have people on their team who are experts.
Yeah.
The real opportunity, I think, for most companies is in these systems where the system itself can optimize. And
just hang on one second.
Oh, yeah, sure.
Sorry, just want to make sure that I didn't lose something here.
It didn't cut out or anything?
I'll edit it if it did.
Oh,
so
good.
if you don't mind just like repeating the last 30 seconds.
Okay, so we're talking about so there's companies that are they're either really, they have experts on their team that are really clear on what they're trying to accomplish. They're trying to train a model. They know exactly the environments they need, and they're most concerned with, can I get this infrastructure to be reliable? And then there are, I think, a completely different customer that's trying to automate something. Like, they're literally trying to take a task that is currently done by humans and trying to get an AI system to do it. And maybe that's not our effectively really should be done by these systems, because it's very clear that we can build optimized environments that are task specific, where if you were to ask your average out of the box coding assistant or agent, that it would either not accomplish or accomplish poorly, to something that is 99% accurate, and it's just as accurate as if you were to tell a human to do it. These are the things that I think are really exciting, because there's just so many. There's so many of these tasks, and
I mean, the types of things that like, do you think that the domain of these is typically going to be in like their computer use, in which it's the terminal interacting with the machine and the resources of the machine, but do you imagine like that end user interface being a part of it as well at some point, or are you like more interested in like the low level stuff, for which maybe coding environments are the ones that might be the most like the first ones to take to kind of to optimize for, essentially? or does it matter to you, or does it matter to you like what those types of computing environments are?
Well, yeah. So I think if I understand correctly, it's a question around the interface.
Yeah.
Like, how do you? And this is, I think, very interesting, and where I think I'm taking a bit of an approach that isn't as common right now, where a lot of people are interested in developer tools. They're interested in they like the workflow drag and drop things, or the new programming paradigms like DSPY. And these are things where ultimately the human is very involved. The human is building the system. And what I am more interested in is the black box, where the approach is more that you build a system that you expect to optimize. You expect that initially it will not perform well, and that you kind of set it just in the same way that these models are trained. Even though we're not talking about training a model always, you're almost training the environment, you're training the system. But that in the same way that you kind of set these models out to, like in the robotics use cases, they need to learn to walk. And initially they're not able to, but you don't try and interfere. You let the model kind of figure this out. And that same approach is the way that I've been thinking about it, but applied to tasks. So it's kind of this black box in a sense, and you let the system optimize. And the problem is not necessarily, the problem is, can you set the system up in a way that initially it's kind of set up for success, to get itself to that end state.
Yeah.
Because that's what we do with reinforcement learning from verifiable rewards, is you're hoping that the model will somewhat figure out how to get to the end state that you want. If you've developed rewards that are high quality, that accurately enforce what you want to accomplish, you will get there.
Yeah.
And so from the initial state, you almost are hoping that you'll get there. And if you've set up your initial environment for success, then you'll get to a good outcome. Does that make sense?
Yeah. No, that totally makes sense. I think I'm very curious to know what you think, where the space is going to go in the next, what are the parts of this space that you're keeping an eye on, right? As a I'm super curious where you think we're going to be in the next 6 months to a year from now, right? What parts of reinforcement learning specifically are you excited about? One, for example, I read about just this morning on Twitter, is this idea of continuous learning, or essentially where the trained weight, essentially the weights are changing as the model is learning. It's not maybe in real time, but almost near real time, right? Where essentially as soon as the model learns something, the weights are automatically adjusted, and essentially inference can be run on those adjusted weights immediately.
Yeah.
Right? Which is a really interesting idea of just bringing speed to the training process in a way that, and I think there's some there's some interesting papers that were shared on that. But I'm curious, what are you excited about in this space? What are you kind of paying attention to that is going to affect what you guys are working on?
I think that there's, I guess if I were to say what's my boldest prediction, to keep it exciting is or most controversial perhaps, is I think that programming is going to go away in a really major way, in a way that people have really not appreciated yet, and that it is going to become clear that it is so much more worthwhile to build these systems than it is to build programs, even telling models to build programs for you. And the reason is that, I don't know, you just take an example of any program. you can say that you've built some accounting software, but why do you need accounting software if the model is doing your accounting for you? You know, like if you've created an environment that the purpose of it is your accountant, and it is literally, and it's like, what is the environment? It's a computer. It has a file system. It has access to the internet. It has a terminal. There's no like UI. It's just the terminal. And it is consuming your financial data from whatever sources. Maybe you're literally drag and dropping it into some, just to upload it. And then it is going to prepare financial statements for you, and it's going to let you know when those are done. And so it's like, well, why on earth would you go and build accounting software? Like, that's just crazy. You can go down the list of things where it's just kind of, we're heading to a world where it's not that software is replaced, it's just not needed in a world where these models are doing actual work. Like, we built software for us to do work more efficiently. There will be things like, I think social media is a great example, or games, like wherever we go with. But, to even push on this point further, because I think something people don't talk about enough is an example that I think is fascinating is VR software. So right now there are thousands of engineers who work on the operating systems for things like Oculus, or Quest, and or the Vision Pro. But there are these models that are still very early today, but that are effectively real-time diffusion models where you are in a kind of stateful, interactive environment. Google had one called Genie, or they've had a series. The latest one, I think, is Genie 3, where if this is the entire program, all you need in order to engage in that game, quote unquote, or whatever it ends up being called, you don't need the software. You don't need software that was designed, like the operating system that's been being built for the last 10 years. You don't need that if it's being rendered for you in real time. And it just becomes, it's almost like a little bit hard to imagine.
Yeah.
But you can imagine, like, okay, you're using a computer and you need an operating system, you need to see your apps or whatever you need to see. I mean, it's like, does that need to be a program, or does that need to be a model that is in real time showing you whatever you need to see?
Yeah.
And there's going to be, obviously, it's not like you completely replace all of, it'd be an exaggeration to say that models completely replace everything. Some programs certainly need to exist in order, but that, I think, is the thing to, and so what does that mean for people, people listening to this, or businesses or what have you? It's like, okay, well, then you are interested in training models. Like, your business needs to compete on training models. You need to find ways that you can have some kind of, people use your product or service, you feed that back into a model or a series of models so that your product and service gets better. Because if you don't, somebody else is going to.
Yeah.
And I think people aren't paying attention to that enough today. Because it's this flywheel that starts where, as you are able to improve,
the earlier you get that data, the more you have an advantage, and it's a compounding advantage, because the more of that data you get, the better your model quality becomes, and it becomes something that, to your very first point, and kind of like what we started our conversation about reinforcement learning on, is like, the people that get this earlier will win, because they will have the natural, the model quality advantage that others sort of missed out on. It's really, really hard to catch up with this kind of stuff.
Yeah, and I think one thing that people say a lot that I don't believe is true is that foundation model labs will always come up with the next thing, and then your model will be obsolete and it'll be this like endless cycle.
Yeah.
But I don't think that's true for the simple reason that, like, let's say you take a classifier off of Hugging Face, a model that, given some text, tells you, like, something about it. You know, maybe it's like sentiment, for example.
Yeah.
But then let's say you trained it on something related to your business, like it's a recommendation engine, and it tells you, based on customer purchase history, this is what the person is most likely to buy. I mean, and now you compare that to, now you have to use GPT-5 to do that. Because it's a classifier, like, it is instilled in the weights things that GPT-5 cannot be necessarily prompted to know. It cannot, I mean, perhaps eventually you could take the input, the context window could be so large that you take your entire order history and every data point that your business has ever collected, and then it outputs a classification. I guess you could imagine that world, but in the world where you've trained a task-specific model, that classifier, is going to just be incredibly accurate in comparison. It'd be silly to use a model like GPT-5 when you have something that you've trained yourself like that. So I think that that's going to continue to be the case, and then you'll be able to reuse that data.
Yeah.
Like, that's the most important part, is as these techniques develop. I mean, there will be new open source models, new techniques, new reinforcement learning algorithms that you can just like continue to optimize. And so that really that data advantage, I think, is real. Like, it can be a moat. Where you can have this agent, what I think another, I guess this is already happening, but another thing I think is not necessarily in the mainstream consciousness as much as it should be, is that, like, people will their product will be an agent. Like, they offer a system that does work, and it does a specific thing, and that is there may not be a fancy interface to it. There's no, like, you just expect that you're going to pay this thing to do X task for you, and that's what the business is.
Yeah.
And so maybe my general observation of software developers in the world, it'll just be people training models.
Yeah. It's very much speaks to Andre Karpathy's Software 3.0 talk that he gave at YC in April of this year, where he just talks about this idea that our traditional way of thinking about programming and programs is not necessarily dead, but it's probably going to reach some kind of plateau and make its way for changing weights and changing the weights of a model as a way of getting things done. And the way to do that is through techniques like reinforcement learning and tools like Everywhere.dev. So I think that let's leave it at that. I think that's awesome, man. Thank you so much for taking the time. And I'm excited to see where what you're going to work on and where